We are now turning a Fabric design into something production teams can run with confidence. This module connects deployment choices, Kubernetes management, security, monitoring, backup, scaling, and governance into one operating model for reliable enterprise blockchain networks. So far, we have moved from Fabric fundamentals into development, integration, operations, and risk. This section connects the reference architecture to a real production environment, with a focus on operational controls and readiness for governance and the capstone. A reference architecture becomes valuable when it is translated into runtime decisions. Operations architecture defines where Fabric services run, who owns them, how they are secured, and how reliability is measured. Peers, orderers, CAs, databases, ingress, monitoring, and backups all need clear control points. The goal is predictable operation across data centers, cloud platforms, and partner organizations, whether the network is handling normal load, failures, security incidents, or change. Deployment model selection is about fit, not finding one universally best environment. Cloud offers speed, automation, and elastic capacity, but it requires strong governance and validated data residency. On-premises deployment provides maximum control and locality, but adds operational burden and can slow scaling. Hybrid models often suit consortium networks because members can keep regulated systems local while using standardized Fabric interfaces for interoperability, compliance, latency management, and disaster recovery. In production, a Fabric network is not one shared cluster owned by everyone. Each organization typically controls its own peers, state databases, certificate authority, monitoring, and application entry points. The ordering service acts as the shared coordination layer, often distributed across trusted parties to avoid single-owner control. Applications connect through gateways near enterprise systems. Then transactions move through endorsement, ordering, and events. The key requirement is secure, observable, governed connectivity across every organizational boundary. Kubernetes namespaces provide the first practical boundary around Fabric operations. Separate development, test, staging, and production, so experiments cannot affect production workloads. In shared clusters, add boundaries for each organization and workload type, such as ordering or observability. Enforce those boundaries with quotas, RBAC, network policies, and isolated secrets. Consistent labels and annotations also make automation, monitoring, cost tracking, and compliance reporting much easier. Each Fabric component should use the Kubernetes primitive that matches how it behaves. Peers, orderers, and CouchDB need stable names, persistent volumes, and predictable recovery, so StatefulSets are usually the right fit. Gateways, dashboards, adapters, and other stateless utilities belong in deployments. Service exposure should stay deliberate. Cluster IP for internal traffic, and ingress, load balancers, or mesh gateways for controlled external access. Keep gossip, ordering, enrollment, application, and metrics paths separate so security and troubleshooting remain clear. Reliable Fabric operations depend on treating state, identity, and configuration as controlled assets. Ledger data, CouchDB, orderer data, and CA databases need persistent volumes with the right performance and backup policy. Private keys, TLS material, and admin credentials belong in Kubernetes secrets or an external vault. Connection profiles, MSPs, channel configuration, and chain code references should be separated and versioned. Certificate rotation and configuration changes should move through approved automation, so trust does not depend on manual heroics. The network is a security boundary, not just plumbing. Fabric components should not all communicate freely in production. Kubernetes network policies define the exact paths peers, orderers, CAs, databases, gateways, and monitoring tools require, with everything else denied by default. Approved traffic should be protected with TLS, and administrative or partner-facing endpoints should use mutual TLS. For external access, add ingress controls, firewalls, VPNs, private links, or service mesh rules, and document every allowed flow. Production sizing starts with workload behavior, not pod counts. Transaction rate, endorsement fan-out, rich queries, event listeners, and ledger growth each place pressure on different parts of the network. Peers and CouchDB need capacity for read-write sets, query load, and storage expansion. Gateways can scale horizontally to absorb client traffic. Orderers and peers should be distributed across failure domains for resilience. Use requests, limits, disruption budgets, anti-affinity, and auto-scaling to keep performance and availability predictable. Observability shows what is really happening inside the Fabric network. Begin with infrastructure health: nodes, pods, storage, network, peers, orderers, CAs, and CouchDB. Then connect those signals to business behavior, including transaction rate, endorsement latency, commit latency, failed proposals, and event lag. Logs should be centralized and linked with correlation IDs, so a transaction can be followed end to end. Effective dashboards and alerts map directly to service objectives, runbooks, and incident severity. Operational readiness has to be designed before production starts. Every major area needs a named owner: peers, orderers, CAs, Kubernetes, gateways, chain code, monitoring, and security controls. During an incident, teams should be able to detect, triage, assign ownership, mitigate, recover, and review without debating authority. Severity levels define urgency. Escalation paths define who gets involved, and runbooks turn common failures into repeatable actions. Regular drills confirm that the model works under pressure. Disaster recovery begins before anything breaks. In Fabric, backups are not just file copies. They preserve ledgers, state databases, orderer data, CA databases, MSP material, secrets, manifests, and configuration history. Each component needs a clear RPO and RTO, agreed across organizations. The recovery plan must then be proven. Restore into isolation, validate channel and chain code behavior, test regional failover, and protect backups with encryption, access control, retention, and audit trails. Production security is strongest when every control is tied to an asset, an operating procedure, and evidence that it works. For a Fabric network, this means governing identities and certificates, protecting keys in an HSM or vault, enforcing TLS and authenticated APIs, and hardening Kubernetes with RBAC, admission controls, signed images, secrets protection, and segmentation. Assurance should remain continuous through scans, audits, access reviews, penetration tests, and evidence collection. The main takeaway is that production Fabric is an operating model, not just a collection of components. Deployment choices must fit compliance, residency, maturity, and recovery needs. Strong teams combine security and monitoring with runbooks, tested backups, and clear ownership. Next, we move into governance, compliance, and solution design.